Okay, so we are going to start with chapter 1, and right now I am only naming it basics. Basics of network theory, NT. Okay, short form. Full name I have already given in a syllabus. So basics of network theory. So first of all, starting the subject, we are going to start. So guys, there's a lot more to discuss, lot more to know. So see this video carefully, right? So basics of network theory. Before going to any components and all, we have to understand about the current. What is the meaning of current? So if someone asks you, define the current, what will you say? You will say the flow of charge is known as the current, or if you are good enough, you will say the rate of flow of charge is known as the current, right? So if I talk about the current I, it is what? Rate of flow of charge. Rate of flow of charge is known as current, and mathematically I can represent it by symbol dq by dt, where q is the charge. And what is the unit of I? The unit of I is ampere, unit of q is coulomb. Okay, units, remember, units को ध्यान रखना, कभी कभार एग्जाम में units को देके आपको घुमा देगा. Okay, so remember the units carefully. So our current is the rate of flow of charge, which is dq by dt is equal to coulomb. Now the question asks, current, is it scalar quantity or vector quantity? Tell me, is this a scalar quantity or a vector quantity? Scalar quantity means only magnitude. Vector quantity means magnitude and direction. For 2 minutes, think about it and pause the video. So I hope you have thought about it. Current. If I talk about my experience, most of the students will say this is a vector quantity because current has direction also, right? And current has magnitude also. But the answer is no, it is not a vector quantity. If you have given option between these two, scalar or vector, then the current is a scalar quantity. Otherwise, we can say current is a tensor quantity. Tensor quantity means which contain characteristic of both scalar and a vector quantity. So if I talk about why current is a scalar quantity, because till now we have learned about the direction of current. It is flowing from left to right, right to left, clockwise and anti-clockwise. So let's suppose I'm giving you one example. So let I1 and I2 are vector quantities. Let I1 and I2 are vector quantities. Okay, मैं suppose कर ले current अभी मेरा vector है, ठीक है? If these are vector quantities, suppose I1 is flowing in this direction, I2 is flowing in this direction, correct? Now, if I add up these two current, you can see, according to parallelogram law of addition, this will be the direction of current, I1 plus I2, according to parallelogram law of addition, right? Now check it. Let us suppose through this I have a I1, so I1 is flowing here. Through this I have a I2 is flowing here, right? In these two pen you can see two markers. Now if I keep this marker here in this direction, so tell me, I1 plus I2 will go in this direction or through the blue marker? Tell me the answer. The answer is simple. I1 plus I2 will go through the blue marker. Means if I put marker here, then, or I can say the wire. Marker is actually representing a wire. So if I put the wire here, the I1 plus I2 will flow through this wire. It will not flow through this direction. It means these are not following the parallelogram law of addition, and because of this I1 and because of this current is not the vector quantity. So again I am repeating, current is not the vector quantity because it is not following the parallelogram law of addition. अगर वो parallelogram law of addition follow करते, तब मैं बोल सकता था it is a vector quantity. But right now I can see it is not following the parallelogram law of addition, right? Then एक question आता है, sir then direction का meaning क्या है? Correct. Question आपका सही होगा. Direction is not actually the direction of current. It actually the direction of path in which current is flowing. Remember this point. The direction which is given alongside with the current is actually the direction of path in which current is flowing. Path can be clockwise, path can be anti-clockwise, it can be straight, it can be zigzag path, right? So remember this point. Current is a scalar quantity, or I can say the tensor quantity, and the direction is actually the direction of the path. Okay? So now I will bring you one question. This is the basic of current. The current का meaning क्या होता है? Now if I bring one question, T equal to 5 seconds. Okay, this is a gate question. You can see this question in your previous year book also. So in this, we have to find a charge till t equal to 5 seconds. We have given a current. So till now, we have only learned one concept, that current is a rate of flow of charge. And you can see from this concept, you will see the previous year question. You will see the 2 or 3 questions. Okay, just a change of graph. So see here, we have given the relation between current and a time, and we need to find out the charge. So I know, मुझे पता है, क्या पता है मुझे, that जो current है I, उसकी इक्वेशन क्या होगी, dq by dt. So अगर मुझे q निकालना है तो क्या होगा, integration of current with respect to time, right? Now always carefully write the limits in case of integration. If I talk about general way, in general way, limit is minus infinity to infinity. Okay, for a general way. But you can see in this question, we need the current is flowing from t equal to 0 and it is flowing till infinity. But we need to find out current only t equal to 5 seconds, right? So what I will put, q is equal to 0 to 5 integration of I dt. Now integration. What is the integration? What is the meaning of integration? Meaning of integration is the area of the curve, right? So you can see from 0 to 5, I need to find out this area, right? Now you can easily find out this area. How? This is triangle, this is square, right? So if I find out area of triangle and area of square, and then I can add up. So total charge will be area of triangle, and sorry, I forgot to give one time here, it is 2, okay? So area of triangle, it is half base into height plus length into breadth. Length is duration, 5 minus 2 into 2. So 2 plus 3 multiplied by 2, you will get 2 plus 6 equal to 8 coulomb. What is the charge till t equal to 5 seconds? It is 8 coulomb, and this is very simple question, you can see. And this type of question has come 2 or 3 times in the previous year GATE exam. Okay, so you can also check it. And you can also see we only need this formula. Okay, so remember these points. Okay. So this is the basic of current, that what is the definition of current, or I can say the rate of flow of charge is known as the current. Now we'll talk about the voltage. Unit, you already know, unit is volt. Now voltage, what I want to know from this topic, the difference between these terms. I have one term potential and I have one term voltage. So can you tell me what is the difference between these two terms? And remember, whenever I ask question, pause the video and think about the answer and then verify it whether your answer is correct or not. So difference बता सकते हो मुझे between potential and voltage में? Tell me, can you tell me the difference? See, the difference between potential and voltage is what? The difference is only of the reference. Unit of both are same, it is volt, right? The only difference is the reference. What is the meaning of reference here? In case of voltage, reference is ground. In case of potential, reference is infinity. Let us suppose I have one point A and I have one ground here. Okay, this is ground, and I am saying potential of A is equal to 2 volt. Then I am wrong here. I have to say voltage of A is 2 volt here with respect to ground. Now the same A, but the reference is infinity. and for this reference the voltage of this reference is 0 volt. Okay, now if the reference is changed, then I have to say the potential of A is 2 volt. Okay, so the only game here is of reference. In voltage the reference is ground. Okay, in potential the reference is infinity. So in our course in network theory, we only see the reference ground. We are not considering infinity as a reference. So for all our course, we are only using the word voltage. In case of subject EMFT, electromagnetic field theory, there the reference will be infinity and you have to use the potential there. But अगर आप दोनों को यूज कर रहे हो, voltage potential यहाँ पे यूज कर भी रहे हो, there is no harm. But you have to keep in your mind the difference between these two terms. Okay, कि voltage में difference क्या है और potential में difference क्या है, right? But अगर आप यूज दोनों वर्ड कर रहे हो तो उसमें कोई प्रॉब्लम नहीं है. Okay, so potential and voltage. Now next two terms is voltage difference and potential difference. So from the name you can guess voltage difference is the difference of voltaging having same reference. Only उन्हीं voltage का difference होगा जिनका reference same है. If the reference are not same, then we cannot find out the voltage difference. Similarly, potential difference. Potential difference is the difference of potential of 2 points having same reference. And if 2 points have different reference, then I cannot find out potential difference. Okay? And earlier I told you about scalar and vector quantity. So voltage and current are actually a phasor quantity. What is the meaning of phasor? Actually, we are going to learn phasor in our chapter 4. Like chapter 4, steady state. In that we are going to learn the phasors. The phasors actually come for the AC quantity. But for the short form, I can say phasor quantity are actually quantities which contain magnitude and phases. And phases come out because of the reference. So all about this, a lot more to discuss about phasor quantities is going in chapter 4. Okay. So now there is a one concept again, power. Very important concept for any student, for any stream, power. So if I ask you what is the formula of power, and we are talking about DC here only. I told you AC we are going to start in a chapter 4. So what is the meaning of power? What is the formula of power? So most of the students will give me answer, sir, V square by R, I square multiplied by R is the formula of power. Your answer is wrong. Why? Because I am not asking you power across resistor. I am only asking you the basic definition of power. So the basic definition of power is voltage multiplied by current, or I can say integration of energy with respect to time is known as the power, right? So the power formula is, and the unit is watt. Now actually the power is divided into two parts. Power absorbed and power delivered. This is the important concept because most of the students will get mistake in that. कैसे? Power absorb deliver actually कैसे पता चलती है? Sign of plus and minus. And if you are not putting a correct sign of plus and minus, then you are getting a wrong answer. Okay? And never ever remember that power absorption means plus, power deliver means minus. No guys, no students, ऐसा नहीं होता. ठीक है? Particular subjects में आप ये बोल सकते हो, but on a general way you cannot say that power absorption का मतलब होता है plus. No. In power system you will learn why we take power absorption plus, but I am talking about network theory here, which is a general use for any other subject. So this conception you should remove from your mind, that power absorption means plus and power delivered means minus. Okay. So then how can we identify whether the power is delivering or absorbing? That I am going to tell you in this particular concept. So before going into this particular concept, I have to understand about two things. Active component and passive component. Yeah. Two terms now come in our mind, which are active components and next is पैसिव कंपोनेंट्स। ओके, ये दो टर्म्स माइंड में आती है, एक्टिव कंपोनेंट्स एंड पैसिव कंपोनेंट्स। सो नाउ व्हाट इज द मीनिंग ऑफ एक्टिव कंपोनेंट? ओके, so first I am giving you a small example. Take one rich guy. Okay, name any rich guy. Everyone knows Ambani. Let's suppose we have some rich guy here, and now we have two ordinary guys here. Okay, now what is happening? This rich guy is giving $10 to this ordinary people every day. Every day he is giving a $10 to these two people. Now tell me, is there any effect on his economy? इसकी इकोनॉमी में कुछ इफेक्ट पड़ेगा? फॉर एग्जांपल मैं अंबानी को दे रहा हूं, अगर अंबानी किसी दो आदमियों को $10 दे रहा है, $10 he is giving to two people, is his economy will get effect? The answer is no. If you see for a 1 year, 2 year, he can easily give $10, right? If you talk about, yes sir, there will be some effect. Yeah, there will be some effect, but that effect is negligible, no? For example, the property, you can think about the rich guy, he's only giving the $10. Okay, so there is no effect on his economy. But if this fellow start giving $5 to him, now their economy will affect or not? The answer is totally yes, because his economy will get decrease and his economy will get increase. Means his economy is changing, the economy are changing, but the economy of this person is not changing in appreciable amount, right? So this is the difference between active and a passive component. Actually, this rich guy is an active component and these two are actually a passive component. So now we can define the active component. Active components are those components which supply the energy. Active components are those components which supply the energy for large amount of time. Okay, so I can define active component are those components which supply energy for large amount of time. एग्जाम्पल दे सकते हो क्या आप? फॉर एग्जाम्पल वोल्टेज सोर्स, और यू कैन से योर बैटरी, योर फोन बैटरी, नॉट फोन बैटरी, you can say the remote battery. You use the AA cell. When you put AA cell in a remote, it will work. It will work for a large amount of time. Why? It will work for a year, for a 6 months, which is a large amount of time. Now, what is the passive component? Passive component are those which absorbs the energy, जो एनर्जी को एब्सॉर्ब करे, ठीक है? फॉर एग्जाम्पल resistor, inductor and capacitor. And one more thing, resistor does not absorb the energy, it dissipates the energy. What is the meaning of dissipates? Dissipates means changing one form of energy into another form. Resistor actually convert electrical energy into a heat energy, but we are putting right now in the absorption case only. So passive components are those which absorb the energy. So this component will transfer the energy to passive components. Now one question you can think about it, that capacitor and inductor also supply the energy, right? So can't they become passive, can't they become active component? The answer is no. You're correct. Inductor and capacitor supplies the energy, but what is the time? For the time duration is just a millisecond or a microsecond. That's why I put this statement here. For large amount of time. Okay. So passive components are R, L, and C. So we will talk about this passive and active in a more much depth. But right now you have to understand these two components, because we are going to define how can we identify absorption and deliver. Okay. So I'm just erasing this one. Then suppose I have one component. If I have an active component, like this, Okay, not active. I can take any component. If I have any component, okay, I'm not taking active or passive. I'm taking any component. If I have any component like this, and the current is entering at a positive terminal, and if the current is entering at a positive terminal, so always remember this scenario. Always tell you that power is absorbing. So this is the power absorbed. That current is entering at a positive terminal. It means the power absorbed. In the same case, if you have again any element means it can be active, passive, it can be linear, non-linear, anything. Inactive element, if current exit from positive terminal, or you can say entering at negative terminal, it means power delivered. It means power delivered. So always remember, in this way we have to identify that power is absorbing or delivering. Now, what is the meaning of plus minus sign? So remember one thing, if in the question they are asking what is the power absorbed through particular element, but actually in the network element is delivering power, then what is the power absorbed? The negative of power delivered. Why? Because of the conservation of energy. What I said, every stable system follows conservation of energy. What is the conservation of energy? That energy can neither be created nor be destroyed, right? Similarly, energy is nothing but power. You can see from this formula. So I can say power can neither be created nor be destroyed. So whatever be the total power delivered, it will be the total power absorbed. So remember this point also, keep in your mind. In particular network, keep this point in your mind. Total power delivered is equal to total power absorbed. Whatever be the total power delivered in a network, it is equal to the total power absorbed in a network. Okay, this point you have to remember. I'm marking a star for these 2 points. Okay, and this is a universal concept. Means if you are in India, in America, in Japan, China, wherever you go, you will have to follow this particular concept. That is the meaning of absorption and deliver. And one more thing, across particular element, power delivered is negative of power absorbed, or power absorbed is negative of power delivered. If I talk about a particular element, for example, I'm saying that inductor is absorbing 6 joule of energy. Okay, I'm talking about energy, power, energy, same thing. So if I'm saying a capacitor is absorbing 6 joule of energy, so I can also say capacitor is delivering minus 6 joule of energy. Okay, plus minus says what? Plus minus says that whatever is asking in a question is opposite to what is happening in a network. मान लो नेटवर्क में पावर डिलीवर हो रही है, लेकिन क्वेश्चन में पूछा है कि पावर एब्जॉर्ब क्या होगा. सो आप क्या करोगे? पावर डिलीवर निकालोगे, उसका जो भी मैग्नीट्यूड होगा पुट माइनस साइन देयर, बिकॉज फॉर अ पर्टिकुलर एलिमेंट पावर डिलीवर इज इक्वल टू माइनस ऑफ पावर एब्जॉर्ब. करेक्ट? Simple thing. Okay, so we will see one question over this also, but first we have to learn about second concept, which is the sign convention. And for today's class, these 2 topics are very much important. Which one? Power topic and the sign convention. Okay, now sign convention. I hope you are making notes, because notes are very much important for this subject, or for any subject you can say. Sign convention, important topic है sign convention. Why? Because through sign convention you have to know how to put the sign across particular element, and if you don't know this concept now, you will never solve any question of network. in every question, or I can say 99.99% of question, you have to follow the sign convention. You have to put the terminals across particular load or a particular element or component. Okay. So what is sign convention? Sign convention means if I have an active element, I told you what is the meaning of active element. If I have an active element and current is like this, okay. So that terminal, let's suppose I'm making it a straight line. Okay, I have an active element. Now the terminal at which active element enters, the terminal at which current enters in an active element is the negative terminal, and the terminal from which it leaves is the positive terminal. So remember this point. This is a universal concept again, that if through active element current is leaving, then that terminal will be the positive terminal, right? जिस टर्मिनल से करंट लीव करेगा वो मेरा टर्मिनल क्या होगा? पॉजिटिव होगा. Similarly, passive element. So in a passive element, the terminal at which current enters, it will be a positive terminal, and the terminal from which it leaves will be a negative terminal. Okay, so in passive component or passive element like R, L, and C, always remember the terminal at which current enters will be the positive terminal, and the terminal from which it leaves will be the negative terminal. Okay, so these sign convention, power convention are the universal concept. You have to use it in every subject, in any country, in every subject. And one important thing, you cannot change this according to your usage or your comfortability. You have to follow this, right? So now I will show you one question, which is actually a previous year question. So this is a simple question. Just for the practice I am giving you for this question. Okay. So tell me, what will the power absorbed by the current source having voltage across it is 4 volt. Okay. Now first of all, you have to mark the polarity across each and every element. How? You can see in this branch which current is flowing? 2 ampere. So if 2 ampere is flowing, you can see this is a passive component. So passive component में जिस terminal पे current enter करेगा, that will be plus and other will be minus. Similarly, you can see through this 3 ampere, the current is leaving from this terminal. So it means it was entering in this terminal. It is plus and minus. And now you can see 2 ampere is flowing here, 3 ampere is flowing here. Then how much current will flow in this wire? Simply I can say how much? 2 plus 3 equal to 5 ampere. So 5 ampere of current will flow here. So if 5 ampere of current is flowing, then you can see what will be the terminal at this particular point. It will be plus, it will be minus. Okay. Now what is given? Voltage across it is 4 volt. So I know the magnitude across it is 4 volt. Right? But we have to put the polarity also. So remember the sign convention. I told you current source is an active element, right? For an active element, current leaves from the positive terminal, and you can see the direction of current is from bottom to top. So current is leaving from the positive terminal, it will be plus, it will be minus. So this is the sign convention across the current source. Now, what is the power? Power across current source. Tell me, what is the power here? I am only asking the magnitude right now. Power here is 4 multiplied by 2. It is simple, equal to 8 watt. It is simple, equal to 8 watt. Now you have to see whether the power is absorbing or delivering. So you can see the current is leaving from positive terminal, and whenever the current leaves from the positive terminal, it actually represents power delivered. Is actually represent power delivered. But see in the question carefully, what is asking? In question they are asking the power absorbed. So in the question they are asking the thing which is opposite, which is happening in a network. So guys, power absorbed will be negative of what we have find out, minus 8 watt. Okay. So this is the meaning of power convention and a sign convention. What is the meaning here? Again, I am asking you, what is the meaning here? The meaning is that what is actually happening in a network? Actually, power is delivering in a network through current source, but they are asking the power absorbed. That's why I put the minus sign here. So always remember, the minus sign is actually tells you whether the things going to according to network or in a opposite way. Fine. So this is nothing but a power criteria and a sign convention. Okay, next question. Okay, next question. Again, this question is from the GATE exam. Next question is from the GATE exam. So the question is, find the value of I. Find the value of I, or not find the range of I. Find the range of I such that 60 volt source absorbs power, or you can say 60 volt source always absorb power. Okay, so in this question we have to find the range of the current I. This is the I now. We have to find the range of a current I such that 60 volt source always absorb the power. Okay, so see here, this is 12 ampere, I is leaving. So tell me how much current is leaving in this direction. It is 12 minus I, right? You can see now, at particular junction 12 ampere is coming, I is leaving in that direction. So what is the current leaving in this branch? 12 minus I. It is actually a KCL that we are going to learn in further classes also. But here you can easily tell this. That's why I am taking this question. Okay. Now 60 volt source absorb power. So first of all, see power across 60 volt. कितना है? It is equal to voltage multiplied by current. 60 multiplied by 12 minus I. Correct? 60 multiplied by 12 minus I. Now in this question they are saying it always absorb power. Now see what is actually happening in a question. Current is entering at a positive terminal, and if current enters at a positive terminal, it means power is absorbing. So actually in a question power is absorbing. This is actually the absorbed power. So if the question is asking that power will always absorb, then this power is actually must be greater than 0. If it become less than 0, then you have to put the minus sign there, and minus sign will tell you what? That actually power is delivering. See, actually power is absorbing, but if you put the minus sign there, it means you are finding out delivered power that I don't require. Correct? So I want that this 60 volt source always absorb power. So for this particular mathematical quantity must be greater than 0. So 60 multiplied 12 minus I must be greater than 0, or simply you can say I is less than 12. Simple. That if you want 60 volt to absorb power always, the current I must be less than 12 ampere. Okay, this is a GATE question, and if I am not wrong, it was only 1 mark question, and it is from the electrical department. So guys, you can see I just started the your particular subject, and we have just spent 30 minutes or 30 plus minutes. So you can see in this 30 plus minutes you are able to solve the 2 question of GATE exam. Which one? पहला कौन सा जो ग्राफ क्वेश्चन हमने ड्रॉ किया, दूसरा कौन सा है ये पर्टिकुलर क्वेश्चन. So these little concepts are important because sometimes question can come from these concepts. But most of the time you will not face this particular question, but for different exams like BARC, your SSC CGL, in that exam you will see this type of question. Okay, but the basic that we are using here is going to utilize in each and every question. Sign convention को तो आप हर question में देखोगे, right? Whenever you will solve the question, आपको sign convention को देखना ही पड़ेगा. तो याद रखो sign convention क्या है कि अगर एक्टिव एलिमेंट में करंट एंटर करता है तो वो टर्मिनल कौन सा होगा? डेट विल बी अ नेगेटिव टर्मिनल. और अगर पैसिव एलिमेंट में करंट एंटर करता है तो वो टर्मिनल क्या होगा? हमारा पॉजिटिव टर्मिनल. करेक्ट? सो दिस वाज ऑल अबाउट पावर एंड द साइन कन्वेंशन एंड एब्जॉर्प्शन एंड डिलीवर का याद रखना. Okay, absorption और deliver का याद रखना. Now I'm going to show you one flow chart. Okay, see carefully. Electrical components. So in actual way, electrical components are divided into two parts. Electrical components are divided into two parts. Which one? Active components and passive component. Correct. Active component and passive component. Active components and passive components. Now, active component is again divided into two parts, ideal and non-ideal, or I can say practical, okay, ideal, non-ideal, or I can say practical. Now again, this practical components divided into two parts. First one is dependent component and next is independent component. Passive component actually divides into two parts, linear component and non-linear component. Okay, so in this particular first half of our chapter, which is the basic of components, right? The chapter name was basic of components and basic laws. So in the first half of our chapter, which is the basic of components, we are going to learn this all. We are going to learn what is the meaning of active component, what is the meaning of passive, what is the meaning of ideal, what is the meaning of practical, what is the meaning of dependent, independent, linear and non-linear, and much more. Okay, and if you don't have understanding about this particular concept, then वो मेरी guarantee है कि आप question solve कर ही नहीं पाओगे. If you have a good concept about this particular, then you can solve the question easily. And one more thing, you will not face the direct question from this particular concept. If you see the previous year question, so only 2 or 3 questions may have come from direct from this particular topics. But every question after that, every concept after that must have used some one or more concept from this particular graph. So this is very important, how to define the electrical components. So I have already told you about active and passive, right? Active components which actually delivers the power, delivers the energy for a large amount of time. और इसके एग्जाम्पल हमने क्या देखे थे? वोल्टेज सोर्स, करंट सोर्स. आई कैन राइट, अगर मुझे इसके एग्जाम्पल देखने हो क्या होंगे? वोल्टेज सोर्स, current source, right? Passive components are those components which actually absorbs the power and sometimes it delivers the power but for a small amount of time. जैसे कि inductor and capacitor, that they sometimes gives the power or gives the energy but for the small amount of time only. So passive components के example क्या हो गए? R, L and C. Passive components के example क्या हो गए? R, L, C. So first we are going to learn about what is the meaning of ideal component. Okay, ideal component का मतलब क्या होता है? Ideal component. So guys, what is the meaning of ideal component? सोचो ideal component की basic characteristic क्या हो सकती है? Power loss must be zero. Power loss must be zero. Constant magnitude right? These two are the basic properties, that power loss is zero and constant magnitude. So in ideal component, we are actually going to see two components, which are voltage source and a current source. So first of all, we will see the ideal voltage source. We will see the characteristic and a plot of the ideal voltage source. So first of all, we are going to see ideal voltage source. Okay, so ideal voltage source actually contain a voltage source only without any resistance. Okay, why? Because if you put some resistance there, then some power will dissipate also. So there is no resistance with the ideal voltage source, plus minus Vt, It. So this is the actually representation of an ideal voltage source, in which voltage source this only contain a voltage source, not any series resistance with it. Okay. So here I can say that terminal voltage is equal to the voltage source. What is the meaning of terminal voltage? Actually, the terminal is actually the terminals are actually the points where you connect the load. Okay. Actually, we are going to connect load here, right? So current through that load is known as the terminal current. Voltage across that load is known as the terminal voltage, right? So you can see that terminal voltage is equal to source voltage. And what is the voltage source actually? Voltage source actually are those sources whose voltage will not decrease. It will always provide a constant voltage. So what this Vs is constant. So terminal voltage is equal to Vs, which is nothing but a constant magnitude, and it is not decreasing with time, right? It is not depending on any other component. So it means what? Terminal voltage remain constant. And if the terminal voltage remain constant, this is the first characteristic of the ideal voltage source. Now, power loss. Power loss is actually equal to IT square multiplied by RS, which is the internal resistance, but RS is equal to 0. So power loss is 0. So you can see these are two characteristics. These two characteristics of an ideal voltage source, that terminal voltage is equal to source voltage and power loss is 0. Now, if I want to draw curve, always remember, curve draws between terminal voltage and terminal current. Now you can see there is no relation between terminal voltage and terminal current, or I can say terminal voltage is always constant to source voltage. So this is the characteristic of the ideal voltage source, which is a straight line parallel to terminal current axis. Now ideal current source. Ideal voltage source, then we have an ideal current source. So current source is what? Which provide a constant current irrespective of the voltage across it. Irrespective of the voltage across it. And what happen? In ideal current source, we have, in an ideal current source, what happen? We have an open circuit here, okay? So here I can put resistance is infinite, because there is no path for a current to flow. That's why resistance is infinite. So for this point, what will be the terminal current? Terminal current will be equal to what? Source current, right? Terminal voltage can be anything. Terminal voltage can be anything. We should not write this. Power loss. What will be the power loss? Power loss will be Vt square divided by Rs, because terminal voltage is parallel to it. So Rs is infinite. Rs is what? It is infinite. So the power loss will be 0. So you can say the power loss is 0 and terminal current is equal to source current. This is the characteristic of the ideal current source. Now, characteristic की बात की जाए, terminal voltage, terminal current. So, terminal current does not depend on any terminal voltage, it is constant. So, this will be the graph of a terminal current, sorry, ideal current source, that we have a straight line parallel to one voltage axis, right? So, this is the characteristic of the ideal current source and ideal voltage source. And in the exam, they have asked you once the characteristic of ideal voltage source that we have already done. Okay. So in the next topic, we are going to learn about the practical sources with some more examples. So one question for you: is there any example in practical life? We have an ideal current or voltage source. Any example? What is the characteristic of ideal voltage source? Characteristic of ideal voltage source is terminal voltage will remain constant, power loss is 0, correct? Terminal voltage remain constant till t tends to infinity. Okay. So is there any source present? Yes, we can say the sun. Sun is acting like an ideal source because you can say it is providing the energy for an infinite amount of time, billion years ago, say billion years पहले से, and next billion years तक it will provide the energy. So it is more close to the ideal source as compared to any other source. Okay, but in practical life we will only see the practical sources. So practical sources क्या होंगे? Simply आप अब तो assume कर ही सकते हो कि power loss 0 नहीं होगा और आपका terminal voltage constant नहीं होगा. If I talk about practical current source, तो terminal current मेरा constant नहीं होगा. Okay? So this thing we will see in next topic, and characteristic, which is very much important for a practical voltage and practical current source.